This video is the Objective 10 formative key. So we put the finishing touches in class on curve sketching and graphing and analysis of the first and second derivative. So the level 2 asks us to work with these extreme values. We know extreme values are based off critical points. And we know critical points are where the first derivative is equal to 0 or undefined. So our first derivative is given to us. It's given to us in a factored form. So our first derivative is equal to 0 if x equals 4, -2, 1, or -6. So I'm now going to go ahead and set up a number line with -6, -2, 1, and 4 on it. This is a number line on f prime. And now I'm going to test to see whether those intervals give us positive or negative regions, hence, or I should say, therefore increasing or decreasing respectively, because based off of that we'll be able to tell if we have maxes or mins. So I'll look at, say, f prime of -7. At -7 I get -11 times -5 times -8 times -1. So a negative times a negative times a negative times a negative, that will ultimately give me a positive region. Then I'll look at another value in the next interval. I'm going to look at f prime of, let's say, -5. And that would give me -9 times -3 times -6 times +1. So negative times a negative times a negative times a positive will be negative. So therefore, by definition, since we're going from positive to negative, we would get a max. Next, I'll go to the following interval, which will be from -2 to +1, and I'll pick out f prime of 0. So I'll get -4 times 2 times -1 times 6. Two positives and two negatives multiplied together, so that will end up being positive. So by definition, that is a min there at x equals -2. From 1 to 4, I'll look at f prime of 3. That'll give me a negative, positive, positive, positive. Multiply that together, I get a negative. So that's going to be another max there at 1. And then at 5, say f prime of 5, everything will be positive. So we go from negative to positive, so that will be a min right there. So I have 4 relative extrema, 2 max, 2 mins, at x equals -6 and x equals 1 respectively, and then at x equals -2 and x equals 4 respectively. Next, level 3 asks us to, given a function, it wants us to sketch the graph. It says use the calculus of the first and second derivative. So I'm going to start by finding f prime of x, which is 3x squared minus 15x plus 12, and f double prime of x, which is 6x minus 15. I'm going to set each of those equal to 0 so that I can get my critical point candidates and inflection point candidates respectively. If f double prime of x is equal to 0, then x equals 15 over 6, or 5 over 2. And f prime, if I set that equal to 0, I can factor out a 3, and I get x squared minus 5x plus 4 equals 0. So I have x minus 4 times x minus 1 equals 0. So x equals 1 or 4. And now from here, I can go ahead and I can set up my two number lines for f prime and f double prime respectively. 5 halves I'm going to put right there. 1 and 4 I'll put right there. For f prime, that's 3x squared minus 15x plus 12. Let's look at some values such as Let's see here. Oops, sorry, I just realized I mislabeled those graphs. Let me start them over again. Sorry about that. Didn't follow my own lines I created for myself. So I should have f prime, 1 and 4, f double prime, 5 halves. F double prime of 0 is negative 15, so we're negative over there. F double prime of 3 is positive 3, so we're positive over there. F prime of 0 is positive 12. F prime of 2 is 12 plus 12 minus 30, so that's negative 6. And F prime of 5 is positive 75. Minus 75 plus 12, that's a positive number there as well. Okay, time to sketch the graph. Given the function, sketch the graph in the interval, justify your answer using calculus and the first and second derivative points. So I've got the critical points, relative, but it also talks about absolute max and min and the inflection points. So here we go. So I know I have a graph that, based off the function, f of 0 is equal to negative 1. So I'm going to go through 0, negative 1. And then for my shape, I have positive, negative, so that's increasing and concave down, up through 1. So that will look like this, to that point. And then from 1 to 5 halves, I have a negative first, negative second, so I'm looking like that. From 5 halves to 4, I have a negative first, positive second, looks like that. And then from 4 to 4 on, look like that. So there's my graph, but I was told I only want this graph over the interval from 0 to 6. So I'm going to cut this graph off and do the following. I'm going to try to delete everything after 6 here. And since my eraser isn't working, I'm going to do the following. So I'm going to say here's 6, and here's 0. So it's really only the red part of the graph that I want. So I've answered all the questions at this point except for the absolute min and absolute max. So I need to remind myself, where do absolute mins and absolute maxes occur? They occur at the critical points or at the end points. So here's how we're going to finish. If I want to test for absolute min and absolute max, then what I will do is I will take the x values of 0 and 6, the endpoints, and the critical points that fell in those values, or in those intervals, 1 and 4. And since I want absolute max or min values, I will put them back into f of x. So f of 0 is negative 1. F of 1 is 1 plus 12, that's 13 minus 1 is 12, minus 15 halves. 12 minus 15 halves is 4.5. How about 6? Let's see here. 6 cubed is 216. Minus 1 is 215. Plus 72 is 287. Minus 36 times 15 over 2, that's 18 times 15. So what do we have? 287 minus 15 times 80, or 15 times 18. So 15 times 18, 225 is 45, so what's that? 260? 287 minus 260, is that 27? Hopefully my arithmetic is good. And then 4 cubed is 64, 64 plus 48, 64 plus 50 is 114, minus 2 is 112, minus 1 is 111. So I have 111 minus 8 times 15, 111 minus 120, negative 9. So what do I now have? Absolute max, absolute min, respectively. And those points are at 6 comma 27, and 4 comma negative 9. Lastly, the level 4, I need to put together this graph. Absolute max of f is 6 and occurs at 5. In addition, f has a relative max at negative 1 and a relative min at 2. So it looks like we got all sorts of scenarios going on here. So I'm going to start by sketching myself a sample graph. So I have 5, 1, 2, 3, 4, 5, 5, 6, and that was a max, so I must be doing something like that around it. Absolute, and that's the absolute max. A relative max at x equals negative 1, and I see a negative 1, 3 as a point, so that was a relative max. Relative min at x equals 2, f of 2 equals 5. So their relative min must look like that. F of 2 is equal to 0, or f of 0 is equal to 2. So it looks like I can put something like this together as the graph. Five. Get rid of that there. So it looks like I now have a graph of f. And again, I'm just following those characteristics on the max and the mins. Well, now I got to take that and go through the transformation. What's the transformation tell me to do? 1 unit to the left, flip over the y-axis, over the x-axis, and then up 2 units. So I'm going to take each of these points, and I'm going to go ahead and I'm going to shift those, and then from there I can get my conclusion. So first I'm going to take this and replicate over the y-axis. I would have shifted this 1 unit to the left. That's what will be in blue here. And then I should shift everything up 2, and that's going to get me my graph over here. Giving me the following there. And therein lies my